Alright, we're going to work right through a whole example here. So we've got a function z of x and y, and we're going to try and find the critical points and the nature of these points. Okay, so the first thing is for the critical points we need to find the two first partials and make sure they're both equal to 0. So we need partial z partial x is equal to, for this function, is going to be 6x squared plus 6y squared minus 150 as the first partial with regards to x, and the first partial with regards to y, just a constant, y comes down, so it's going to be 12xy minus 9y squared. Okay, and we need both of these equal to 0. Okay, so both of these things have to be equal to 0, so it doesn't matter which one we attack first, but I'm going to have a go at this one first just because it's got the x isn't squared effectively. This is a bit more complicated to unravel. So if we try setting this one equal to 0, so let's set the first partial with regards to y equal to 0, which implies that 12xy minus 9y squared equals 0. You can factor a y out of that. 12x minus 9y equals 0, which implies that y equals 0, or this part here equals 0. 12x minus 9y equals 0, which we could rearrange to say that x equals 9y over 12, or divide both things by 3/3 of y. Okay, for this part, so if y equals 0, going back into this equation here, then 6x squared minus 150 has to equal 0, because we know that this whole thing is equal to 0, because both the first partial is equal to 0, which implies that x squared has to equal 25. So x equals plus or minus 5. So with y equal to 0, the points are in the form xy 5, 0 and negative 5, 0. Okay, so that's two critical points based on the fact of what happens if y equals 0, and the other ones we're going to work out is if x equals 3y over 4. So we're going to substitute this x for 3y over 4, then 6 lots of 3y over 4 squared plus 6 lots of y squared has to equal 150. So a little bit of rearrangement. What do we get here? We've got y squared out the front, obviously. We've got 9 6s, 54 over 4 plus 6 equals 150, and we could, what's that going to be? It's going to be 24 over 4, so that's 78 over 4, so y squared has to equal 150 times 4 over 78, which, if we grab a calculator, hopefully it's a nice square number. What have we got here? We've got 150 times 4 over 78 equals not a number I was expecting at all. So what have I done wrong? I was expecting 16. I may have to go back and check it. So what have I done? That's what I've done. 4 squared is 16, not 4. So it should be over 16, which means that that's going to be 16, and it's going to be 16 times 6 is 96. That's going to be 150 on the bottom line. 150s cancel out, and we're left with 16. It always pays to have done it beforehand and know what the answer is. So y equals plus or minus 4. Okay, and we can now know that if y is plus or minus 4, we can work out what x is. Okay, so when y is positive 4, x is going to be 3, and when y is negative 4, x is going to be negative 3. So the points are in the xy form. Okay, so x is 3 when y is 4, and x is negative 3 when y is negative 4. Okay, so I found those again by sticking these values of y back into this equation here. So when y was 4, the 4's cancel out and x is just equal to 3. And when y is negative 4, the 4's cancel out but leave a negative, so x is negative 3. Okay, so I have my 4 points that I'm working with. So there's 2 of the points, and there's the other 2 of the points. Okay, so I've found my 4 points, and now all I need to do is find the natures of those 4 points. So again, I'm going to do this the same way as I did it in the previous example. I'm going to do it by drawing a table. So my table looks like my points. So my points are 5, 0, negative 5, 0, 3, 4, and negative 3, negative 4 are the 4 points I'm interested in. And for each of these points, I need to work out the second derivative with regards to x, which is going to be, go back up, find my first derivative with regards to x, this one here, and differentiate that again. So it's going to give me 12x. And then I need my second derivative with regard to y, which is up here. So if I differentiate this thing again with y, I get 12x minus 18y. And then I need my second partial mixed. Okay, so that's my first partial with regards to x, now done with a y. So that's going to give me 12y. Okay, so that's the things I need to do. And then I'm going to do the check factor, which is the second partial x times the second partial y minus the second mixed partial squared. Okay, so that's the thing. That's my key check thing. And then over here, I might as well just put a column for the nature once I've checked those things out. Okay, so what have I got here? So let's try and draw some lines, which is not always the easiest thing to do, but that looks doable. Okay, so if x is equal to 5, 5 12s are 60. This point here, x is 5 and y is 0, so that's going to be 60 again. The second partial is just 12 lots of y, so that's 0. So the mixture here is 60 times 60 is 3600. Okay, so that's that row done. Negative 5 is going to give negative 60, another negative 60, again 0, multiply those, so again is going to be 3600. If x equals 3, we get 12 3s are 36, and here we get 36 minus 4 lots of 18, which is 72, so it's going to be negative 36. 12y is going to be 48. And this thing here, good grief, what's got here? So it's that one times that one minus that one squared. Well, it's going to be some negative number, and that thing squared's positive, so when you take it off, it's going to be negative. So the whole thing's going to be negative. I don't really care what the value is, I just know it's negative. And this one is negative 36, and then we get 36, negative 36 plus, that's going to be positive. And this one's going to be negative again. So again, that times that's going to be negative, square that's going to be positive. When you take it off from that, it's going to go even more negative. So what I need to know is that's negative. And then I can look at my check to see what's going on. So basically the main check is this thing. So if this thing is negative, we're looking at a saddle point. Okay, so these two here are straight away, we know they're both saddle points. Okay, because this one is less than 0. Have a look back at the previous page for the rules if you need them. Where this thing is greater than 0, as is the case here, we need to check back over here. So these two are either maximum or minima. The fact that these two things are both positive means we're looking at a minimum. And the fact that these two are both negative means we're looking at a maximum. Okay, so this function has 4 critical points, 1 maximum, 1 minimum, and a couple of saddle points. Okay, so that's a process which you definitely need to be able to work through.